Alright, this is our Unit 4 video on piecewise functions. Few questions on piecewise here. We're going to start with this function f of x at the top. There is a typo here. This should say we're going to use this equation for number 1 and number 2. So number 1, all you're going to do is you're going to evaluate the piecewise function that's up above. So it says you need to find the value of f of 5. Now 5 is your input, your x. So you need to look at the domains of this function right here. The first equation, 2x, is only used for the x values from -1 to 3. The second equation here is used on the domain from 3 to 6. 5 falls into that second domain. It's in between 3 and 6. So you're going to put 5 in to the bottom equation. You'll have -5 minus 4, which equals -9. When I look at B, I'm going to start the same way. 3 is an x value. 3 is in the domain for the top equation, right? 3 is equal to 3. That's why we use the top one. I know there's a 3 in the bottom domain, but 3 is not equal to on the bottom. It's only equal in the top. So you would take 2 times 3, which equals 6. That's the value of f of 3. For C, f of -1. The -1 is in the domain again for the top equation. -1 is in that inequality. So you'd have 2 times -1, which is -2. All right, D asks you for f of 6. 6 is in the bottom domain here, right? It's from 3 to 6. So I'll have -6 minus 4, which equals -10. And finally, f of 2 equals, 2 is in the top domain. It's between -1 and 3. So we'll put 2 in for x in the top function, which equals 4. Alright, question 2 here uses the same piecewise function, but we are going to graph the piecewise. Now remember, when you graph a piecewise function, the values that go in the x's, in the x column of your table, are the x's from your domains. So you need the x of -1 and 3, and then you need the x's from the bottom domain. I'm going to skip a space just to keep it organized. 3 to 6. Now let's talk really quick about the dots we're going to use. At -1, there's a less than or equal to symbol, which means on your piecewise graph you will have a closed dot. Same thing here at x equals 3. It has a less than or equal to, so that will also be a closed dot. When you connect those, it's going to be a segment with 2 closed dots. At x equals 3 in the bottom domain, it just says less than. That's going to be an open dot, and 6 is going to have a closed dot. So when you graph that, it will be a segment with 2 endpoints. One's going to be open. So now you use the corresponding part equation to that domain to find the y values, right? So for -1 here, you put -1 into the function 2x, 2 times -1, and you'll get an output of -2. So to plot that, you'll plot the point -1, -2 with a closed dot like we identified. 3 is also from that equation, so 2 times 3 is 6. So you're going to plot the point 3, 6 with a closed dot, and then all you have to do is connect those. That's the left segment of this piecewise function. For the second equation, you're going to put 3 in for x into the bottom equation. So you'll have -3 minus 4, which is -7. So the point 3, -7 has an open dot, and you'll put in -6 minus 4 here, which is -10. So 6, -10 gets a closed dot, and you can connect those. That is the piecewise graph from number 1 and number 2. Now number 3 and 4 use the graph that is given to you right here. First, we're going to evaluate the piecewise function from this graph. So we're going to look at g of -2. That -2 is an x value. You go to -2 up to the function, like when we did the Unit 2 video, and the output is 4. Most of this is pretty simple. G of 3, you go to where x is 3, up to the function, you get an output of 3. Same at 1, you go to x is 1, up to the function, the output is 3. Negative 1, up to the function at 2. The only difficult part of this whole function is looking at g of 0. When I look at 0, I notice I have a open dot and a closed dot. You need to use the value at the closed dot. The open dot means it's a placeholder, but there's no actual value for the function there. The closed dot is where you have the value, which here is at 3. Now you need to write the equation for this piecewise graph. So we're going to start with the left portion here, which is a ray. Right, this portion we need to write the equation, and the equation is going to be in y equals mx plus b form. Okay. So for that, you have y equals, the slope of this left portion here, if I pick 2 points off, is down to right 1. So the slope of negative 2, you put your x, and the y-intercept for this portion is right here at the origin of 0. So it would be plus 0. However, you don't have to write plus 0, so you could just write negative 2x. That is the equation. The domain for that portion, if I worked left to right, there's an arrow going to the left here. So if I think about interval notation, that would be negative infinity up to the rightmost for that section is at 0, which has an open dot. But when I use piecewise functions, I don't want to use interval notation. I need to use inequalities. So that means all these x's, if they go from negative infinity up to 0, those are all the x's less than 0. So we're going to use the inequality for our piecewise domain here. The right portion equation is a horizontal line, and horizontal lines are always of the form y equals, and it's the y value that it crosses the y-axis at, which is 3 here. The domain of this is going to be a compound inequality. We start from the x value of 0 right here. We go until the x value of 4. And when you write those compound inequalities, it's going to look similar to the domains that we had in problem 1 and 2. The x goes in the middle. And since there are 2 closed dots on this graph up here, you're going to have less than or equal to as your symbol for both. Now when you transfer that to actually write piecewise function here with the curly bracket, you write the equation first, put a comma, and then write the domain that goes with that piece. And then the last one, you write the 3. You don't have to write y equals. That's right here with the g of x. That's y. And then you write your domain for that function. Okay? That's your review of piecewise functions. Hopefully that helped a little bit there.